In what ways does projectile motion resemble free fall? So I've gone ahead and before starting this question, I've drawn kind of a sketch of projectile motion here across level ground. And I've chosen three spots to look at the components of velocity, in other words, the components of motion. And I started at the top here where I think there the vertical component would be exactly zero and it would just have a horizontal component of motion. And since horizontal component of motion is inertial, that's going to remain the same. So ideally these horizontal arrows should all be the same length at each spot. I drew them by hand so they may not be perfect. But as you go and progress through these three spots that I've chosen here, the horizontal component is increasingly pointing down. And in that sense, if I were to say, hey, what would you describe if I just took an object here and released it from rest and then looked at like what would its velocity be at points along its fall? And we know that its velocity would be increasing as it did so. The mathematics that describes these velocities as a function of time are actually going to be the same as these vertical components of velocity for projectile motion. So that actually answers this question. For projectile motion, the vertical component is essentially free fall. You know, we usually think of free fall as an object released from rest, but what if instead of releasing an object from rest, I had tossed it up and then it, went up to some height and fell back down? Well, one way, in light of that, you can think of projectile motion as a combination of an object that was tossed up and it's moving with inertia horizontally at the same time. So that's kind of our picture that really we kind of got from Galileo. We've maybe added some math to it these days that he didn't have yet. But there's the answer. It says the vertical component of motion is the same as free fall. The acceleration vector in particular, that means, I didn't address that yet actually, but that means it's accelerating the same as for free fall. And we're in a chapter on vectors, so I'm saying that means the acceleration vector. In other words, what's amazing about this, going back to my picture, is like if somebody asked what's the acceleration vector for this picture, it would be, so like if I maybe drew to the side of it and said, okay, here is like, I don't know what scale this would be on, so the length doesn't really mean very much here, but I would say the acceleration for free fall is just an acceleration vector that points straight down. But if somebody asks like, well, what's the acceleration vector for this projectile motion, it turns out it's exactly the same thing. The only reason why things look different is if somebody threw this object or however it was launched, it was given an initial horizontal component of motion. Since the acceleration vector is straight down, that horizontal component of motion just moved with its own natural inertia, and the vertical component did what it does naturally given the fact that it's accelerating down.